watching Simplify Your Concept.
Today's video is all about the various types of single-phase transformer. So let's start the video. So a transformer is basically classified into different types based on various bases. So let's see them all. So first, based on the power supply, a transformer could be a single phase or a three phase. So single phase transformer will utilize a single phase supply, whereas the three phase transformer will utilize three phase supply. The next classification is based on the construction of the transformer. So based on the construction, the transformer are of two types. One is core type and the other one is called as the shell type. This we will see it further in this video. Based on the service provided by the transformer, it could be of distribution type or it could be of power transformer type. So distribution transformer, as the name says, will be utilized for distribution system where the voltage will be of low, whereas the power transformers are generally used for transmission system where we are going to use high voltage levels. So now next, based on the function which is performed by the transformer, we have the step-up transformer and the step-down transformer. And we know then that step-up transformers are the ones in which the secondary voltage will be higher than the primary voltage. In case of step-down, the secondary voltage will always be less than the primary. So this is how the classification is done. Now let me tell you with a small example how a transformer is customized. So let's see that example. So let us take, there is a manufacturing company, a transformer manufacturing company. So now a customer comes to the manufacturing companies and tells his requirement. Like he needs a single phase transformer. He just says that he needs a single phase transformer. Then the manufacturing company will further investigate the customer whether this single phase transformer will have a shell type of construction or a core type of construction. So the customer could say that he needs a core type of transformer, not a shell type of transformer. Further, the manufacturing company may ask them whether they need it for step up or step down voltage. So, and the customer may say that he needs it for stepping down the voltage, not for stepping up the voltage. Now this transformer will be basically utilized for distribution system. And the specifications are given by the customer to the manufacturing company. Now based on this specifications, the manufacturing company is going to customize this transformer as a single phase transformer having a core type of construction which will be utilized to step down the voltage in the distribution system. Okay, so this is one way of customizing the transformer based on the customer requirement. Now let me take another example. So the same manufacturing company is there and another customer comes here. Say I say this is customer 1 and customer 2 comes here and he says that he needs a three-phase transformer. So same questions will be asked to the customer that whether the construction should be shell type or core type. So now this customer needs a shell type transformer, not a core type transformer. Now further, he also says that he is looking for step up transformer, not a step down transformer. So he needs a step up transformer, not a step down transformer. And he says that it will be utilized as a power transformer. So finally, based on the specifications provided by customer 2, the manufacturing company is going to customize this transformer as three-phase shell type transformer, which will be used to step up the voltage as a power transformer. So as I told you that the power transformers are basically used for transmission systems. So this is just an example to make you understand that how basically a transformer is customized for its design based on the customer's requirement. So now I will explain about the transformer that are classified based on the construction. So now as we know that based on the construction, the transformers are classified as core type and shell type transformers. So let's see the comparison here. And here is the basis for comparison. The first one is based on the construction details. So as you can see, this is the figure given for the core type of transformer and this is for the shell type of transformer. So in core type of transformer, as you can see here, the windings are encircling the core. So now if I say this is the core of the transformer, so this is the core of the transformer and the windings are placed on the side limbs of the core. So as we can say that the windings encircles the core. Whereas in case of shell type transformer, as you can observe from the figure that the core basically encircles most part of the winding. So the windings are placed on this limb is called as the central limb. They are placed on the central limb and the core basically surrounds this winding. This comparison is based on the construction. The next one is based on the magnetic circuit. Now, once again, based on the magnetic circuit, a core type transformer has a single magnetic circuit. Now, what do we mean by magnetic circuit? As I have also explained previously in the previous videos of transformers, that this is the core and this provides a magnetic path for the flux to flow. Now you can see here there is only one magnetic path or one magnetic circuit for the flux to flow. Whereas in case of shell type, we have double magnetic path or two magnetic. So this portion is one magnetic path and this is the second magnetic path. So the flux here will flow like this. Here it will be 5 by 2, here also 5 by 2. And finally in the outer mode, it will be completely as 5. So here in shell type, we have two magnetic circuits. Coming to the type of winding. So the core type transformers uses concentric or cylindrical type of winding. So they are of cylindrical nature. Whereas in case of shell type, we use sandwiched or disc type of winding. So here the windings which are used, they are being sandwiched with each other. So they form a sandwich type of structure. So that is why they are known as sandwich or disc type of windings. Now the next one is based on the core limbs. Now what are limbs? Limbs are also called as the legs of the transformer on which we place the winding. So these are the two limbs. This is the first limb and this is the second limb. So in core type, we can see here we have two limbs, okay, for a single phase transformer. Whereas in shell type, how many limbs we have? Three. This is the first limb, this is the second limb and this is the third limb. These two, this one and this one, are the outer limbs and this center one is called as the central limb. So coming to the next one, that is based on the cooling system. As we can see here, the windings are basically distributed. They are surrounding the core. So natural cooling is more effective in case of core type. Whereas in case of shell type, the windings are surrounded by the core. Okay, so that is why natural cooling is not possible. We need to provide forced cooling in case of shell type of transformer. So now let's see further some more differences. So now based on the maintenance, a core type transformer, the coils in the core type of transformer can be easily removed for maintenance. Now suppose there is a short circuit happens or there is an insulation failure and we need to remove these windings for maintenance purpose or maybe some detection of the faults or anything like that. Then what we can do, we can just remove these windings as they are surrounding the core. It can be easily dismantled. Whereas in case of shell type, as we see here, for removing any part of the winding for maintenance, large number of lamination of the core need to be removed. As the core surrounds the winding here, we need to first remove this core and only then we can remove the winding for maintenance. So in case of shell type, maintenance is little difficult. Now coming to the next one, that is based on the copper requirement. Obviously this core type of transformer requires more copper for winding, whereas in case of shell type we need less copper for winding. The next one is based on the insulation. As the core type of transformer need more copper for winding, then definitely it needs more insulation. So each winding, each turn need to be insulated from each other. So here the amount of insulation needed is higher. In case of shell type, we require comparatively less insulation. Now the output power of a core type transformer is low, whereas a shell type transformer gives high output power. And the final one, based on the application, this core type of transformers are preferred for low and medium voltage applications. So they are generally used for distribution system for stepping down the voltage. Whereas shell type of transformers are preferred for high voltage applications. So they are preferred for as power transformer to step up the voltage. So these are the few bases for comparison of core type and shell type of transformer. So that's all for today, and remember, work hard to see the magic. Thank you so much for watching, and see you in the next video.